Welcome to this complete and beginner-friendly introduction to CNC, or Computer Numerical Control. This video explains everything you need to know about CNC machines, programming, tools, working principles, and CAD/CM workflow. Whether you are a student, machine operator, engineer, or someone starting a career in machining, this video provides a strong foundation. CNC stands for Computer Numerical Control, a technology that allows machines to be controlled automatically through computer programs. Instead of human hands, a CNC machine uses digital instructions, servo motors, precision control systems, and computer programs like G-codes and M-codes. This makes CNC one of the most accurate, fast, and reliable machining technologies in the world. CNC machining is essential in modern industry, providing high precision up to microns, faster production speeds, and the ability to machine complex shapes. It also offers high repeatability, reduced human error, lower long-term costs, and a safer working environment. From aerospace to automotive, electronics to medical devices, CNC technology is used everywhere. CNC started in the 1950s with simple punch tape machines at MIT, evolving through NC, early CNC, and microprocessor-based systems. Today, it includes CAD/CM integration, high-speed machining, multi-axis capabilities, and modern AI-driven smart CNC systems. A CNC machine is made up of several major components, including the CNC controller, which is the brain of the machine. The spindle rotates the cutting tool, while servo motors precisely control the movement of each axis. Other components include the machine structure, tooling system, work holding system, and coolant system. CNC machining follows a complete digital workflow, starting with 3D design in CAD software. Next, tool paths are created using CM software, which then generates G-codes and M-codes that the CNC machine understands. The CNC controller executes these commands, leading to the machining process where the cutting tool removes material. Finally, the part undergoes inspection for accuracy using tools like calipers, micrometers, or CMM. CNC programming uses G-codes for geometric commands like rapid movement and linear cutting, and M-codes for miscellaneous functions such as spindle control and tool changes. Understanding these codes is essential for CNC programmers, operators, and machinists. CNC machines come in many categories, including CNC lathes for cylindrical parts and CNC milling machines for complex shapes. Other types include CNC routers for wood, laser cutting for precision, plasma cutting for heavy metals, and water jet cutting. There are also CNC wire EDM for die making and CNC 3D printers for additive manufacturing. Perfect machining requires optimizing cutting parameters like spindle speed, feed rate, depth of cut, and tool material. When these are optimized, machining becomes faster, smoother, and more accurate. CNC offers extremely high accuracy, faster production, and the capability to machine complex shapes. It also provides reduced labor costs, perfect repeatability, a safer working environment, and mass production capability. However, disadvantages include expensive initial investment, the need for skilled programming, and maintenance costs. But long-term results always justify these costs. CNC is used in almost every major industry, from aerospace and automotive to medical implants and defense technology. It has become the standard technology for precision manufacturing. To become a CNC operator or programmer, you need to learn machine operation, tooling knowledge, CNC programming, and CAD/CM software. This field has high demand and offers excellent earning opportunities. The future of CNC is evolving with AI-powered machining, robotic automation, and IoT-enabled machine monitoring. Hybrid machining, faster spindle technology, and fully automated factories will continue to dominate global manufacturing. CNC technology has a bright future and will continue to transform industries worldwide.